Okay, welcome back. So this is our second video for week 12, and we're going to continue talking about sets, symmetry, and how I actually would go about analyzing a piece like this using set theory, including how to choose where a set starts and stops, things like that. So last time we were looking at this earlier part of the Crucifixus movement. Now we're going to look at this part here. If you haven't already, please pause this video and go listen to it again before we start. Okay, and now I'm going to assume you're back, and we're going to take a look at some of these Crucifixus sets. So we're actually going to focus on what is normally the vertical arm of it. If I go back to that piece. We're going to focus on this part, the vertical arm. I have already rotated it, so I've excerpted just that part and rotated it like this so that I can see it better. So I want to start by looking at each little part of this and talking about how I would choose to segment it. This particular movement is maybe not so ambiguous as to how you might segment it. And by that I mean, like, how do you decide, like, is this a set? Or do I take the grace note out? Is this a set? Once again, do I take the grace note out? Does it matter? How significant is it? Or do I include the left hand or just the right hand, and so on? So one way I determine that is by listening to it and trying to decide which things go together as gestures. And here I would say that the left and right hand on the grace note definitely go together. So one thing you could do would be to possibly just look at the grace notes, in which case you'd end up with something like this. Like the set is those pitches to the left of the bar and left of the little beam, and these two by themselves. I think that it might make sense to do all of this together, to look at all of that together as one set. And I think that because, again, they're gesturally happening kind of together, I think that the grace note usually should count. And then if we look at what comes after it, we have this little moment, and then 5 seconds of silence. And then another, here, I'll go ahead and draw those together. And then 5 more seconds of silence. And that's what this means, is that it's not just a fermata, it's 5 seconds of nothing. This is similar to what happens on the first beat, but not quite the same. And same here. This is similar, but not quite the same to what just happened over here. And then we get somewhere in between a few notes. Oops, wait. See what I did there was that I didn't notice the grace note. And we want to be consistent. We either always take the grace notes into account or we aren't going to. So it's like, if you want, you could just look at the grace notes and see what kind of set they make, kind of left to right. That's fine too. And then here I'm thinking that this will all be one thing together. It's possible we could also like divide it into groups like that. And I think we can decide that when we get there and see how many notes are repeated and so on. And then here's this one at the end. And we don't want to also forget this cluster right at the beginning. So segmentation in a piece with more kind of distinct layers or more types of sets happening at once, or I don't know, kind of a busier right and left hand that we're working more independently, it could be a little bit harder to figure out like what should go together. And that's one way that I think set theory is still very subjective. Like, it's, again, not just the same as I'm going to punch everything into a calculator or a computer and it will spit out an answer about whatever I want to know. That's just not how this works, actually. This is actually pretty subjective in the sense that it's left up to the analyst to make decisions about what's important and what's not important, etc. So I am going to pull up my set theory calculator. to start looking at the first little cluster. And let's go through and we'll do maybe not every single one, but we'll do a bunch of these. So here, and this is a time when you have to get right up next to the score. Sometimes people use a magnifying glass to look. We'll start with the left hand first. So count your ledger lines. That's a D flat. And that looks like a C natural and a B. This is in the treble clef. We've got a B flat again, so that's already accounted for. We don't need to press it twice. A, C, E, G, sharp, and A natural then right above it. And if I submit that, then I can see what set class I have here. And for right now, I'm not going to worry about the normal form and the particular set. I'm going to look more at the prime form, I think. Look at the interval class vector. It tells you a couple things just at a glance. One is that, look how many, in the first column, remember that the interval vector corresponds to different pitch class intervals that are happening within this set, and the first column represents semitones, meaning that we have 3 semitones overall in this set. So it's going to sound pretty dissonant. Like that's one thing that the interval class vector can tell you, is how dissonant is this going to be really? So lots of 3 semitones, I guess I think that's a lot. 2 major seconds, still kind of a lot. 2 minor thirds, 2 major thirds, or 6 in this case. 1 perfect fourth or fifth. But among all of those other notes, I feel like it's probably not going to sound much like a perfect fifth. And no tritones, somehow. Somehow we have no tritones in that set. So now let's note 0, 1, 2, 4, 5. I'm just going to note that over here in my score. But that's 0, 1, 2, 4, 5. And then I want to go on to the next one. I'm just at this point kind of taking an inventory of what's here, remember. Scoot this over a little bit. Yeah. Okay, so over here, now we've got E, B flat, D natural. I think that that is a flat on the B. And then we've got A, C, D sharp. I know that that's a D sharp, and you probably could just know that from glancing at it, but it's really okay with Crumb to take your time and really try to make sure you are reading his handwriting correctly. And then 9 for A, B's 11. Dang it. So we've got 4, 10, 2, 3, A, B. Then we've got 0, 1, 2, 5, 6, 7. So an interesting thing about this one that makes me think we should kind of draw attention to it a little differently. You can tell, first of all, look at the IC vector. We've got 4 semitones. That's a whole lot. And 2 tritones. And some other things. Every kind of interval class is present here because this is a really dissonant set. So note that we could sort of divide this in half. 0, 1, 2. So there's like C, C sharp, D, 2 semitones already, and 5, 6, 7, 2 more semitones. And it's sort of like we have 2 versions of 0, 1, 2 kind of put together. So I kind of want to make some notes about this because there's not a ton of room on the score. I'm going to put it here in my on-screen notes. This is the vertical arm. We started with 0, 1, 2, 4, 5, and then we had each is a cluster between the periods of silence, I think is how I'll say this. Okay. 0, 1, 2, 4, 5 was the first one. The second one is, what did I just say? 0, 1, 2, 5, 6, 7. This is really like 0, 1, 2 in the left hand, and 0, 1, 2, oops, in the right hand. Now, before we go on to the next little cluster, I want to know, how is this 0, 1, 2 related to this 0, 1, 2? So let's take a minute and figure that out. Let's note them by their pitch names here. We've got, in the left hand, we've got 4, 10, and 2. Oh, interesting, actually. They're not 0, 1, 2 and 0, 1, 2 the way that they're actually voiced. Are you seeing that? So it's not 0, 1, 2 in the left and 0, 1, 2 in the right. We're going to come back to it. We'll come back. We'll leave this blank for a second. Anyway, 4, 10, and 2. And they're not really plus. I don't want to confuse you with math. 3, 9, and 11, right? Or it's probably 11, 3, 9. Anyway, so let's see if those are related in any way. So let's do it over here again. We've got 4, 10, 2. That's 0, 2, 6. And over here, we've got, oops, sorry, too far, right here. We've got F sharp, A, and B. And that's 0 too far. Oh, wait, it's not F sharp, is it? Wait. It's D sharp, A, and B. And guess what? That is also 0, 2, 6. So they are the same. They're not the thing that I thought they were. That's fine. So those things are the same set. So let's figure out if they're related, how they're related, probably by transposition, right? Let's go back to the one that we started with in the left hand. I guess I'm somewhat predisposed to look at the left hand first, but not really for any official reason. So 0, 2, 6. We looked at that, right, on in the other video to look at, we saw it in the top voice of that triad strain. We looked at its interval class vector to note that it has like this interesting symmetrical pattern. Okay. Anyway, so let's see what we have to do. 10, 2, 4 is its normal form. Let's see what we have to do to end up with 3, 9, and 11 over, not here, but over here. 3, 5, and 11. 3, 7, 9. 5, 9, and 11. Oops, one more. We didn't come up with anything, did we? Let's double check it. 3, 9, and 11 is what we're looking for there. 4, 5, 3, 7, 9. 5, 9, 11. In which case, instead of being related by transposition, let's look and see in what way they are related by inversion. Oh, and there we go right away. T1I, meaning these are related by, if you invert and then transpose it, you should end up with 3, 9, 11. So let's try it actually. So we already know the normal form from the set theory calculator is 10, 2, 4. So we're going to start with 10, 2, and 4 in normal order, we know. We're going to invert them along the axis of 0 to 6, which is what we would normally do. Inverted becomes, let's invert it along that. And think about for a second what that set theory clock face looks like. I'll pull it up real quick. Okay, so let's look at 10, 2, and 4 here with both of these in front of us. 10 is going to become 2. So 2, oops, I already gave myself a space to write this, didn't I? 10 becomes 2, swing around like that, and then 2 also is going to become 10. And then 4 is going to become 8, right? So inverted, if we go back to the calculator for a second, if we just invert it without transposing it at all, it becomes 8, 10, 2. But we want to get it to being 9, 3, and 11 because that's what we have here in the score. So then we take 2, 10, and 8 and add 1 to each of them, right? Because that's the operation that the set theory calculator told us gets us to this inversion. I just stopped doing it. Okay. So then we're left with 3. 2 plus 1 is 3. 10 plus 1 is 11. 8 plus 1 is 9. So 3, 11, 9. And that's what we know has showed up as our next set class in the piece, or our next set. So that's, anyway, the relationship between the right and left hand here. Let's add that to some notes. These two instances of 0, 2, 6 are related by T1I. You might be asking yourself, Dr. Shoup, is there a way that we could have done that without using the set theory calculator? And of course there is, but I'm not going to worry about it for right now. One way that you could have known that they had to be related by inversion and not just transposition is that they had to be related by transposition and inversion and not just transposition, is that there's no common kind of integer that you could use. Like, there's no way to get to, it's like from 2 to 11 is 9, but from 10 to 9 is 1, and 4 to 3 is 1, so it's like, okay, well, maybe that's it, but it's not, obviously. Or maybe, you know, from 4 to 9 is 5, and from 10 to 3 is 6. Like, you could try to add them up in different ways, but there's no common, you know, additive number between them. So instead, that means that they have to be related by transposition and inversion. Okay. Put that there. Okay, so in any case, so we have two instances of 0, 2, 6. I want to note that that's what's happening in the smaller set down here. And then I'm going to note the bigger set altogether up higher. So what did we say? We have our 2, 4, 10. That was the left hand. And then let's add to it 3, 9, 11. In which case we had 0 and 2, 5, 6, 7 as our larger set, which is also comprised of those subsets. So it's possible that you can look at sets and that you can look at subsets, and both might be relevant or they might not be. You just have to sort of see over the long-term kind of course of studying the piece. Let's look at this next one again, taking the grace notes into account. So we've got B flat in the left hand. Notice that that has been in the left hand in the previous chord too. B natural in the right hand. G, A, F. And we don't, and then A and B we already have. So if they're, you know, redundant, that's fine. 0, 1, 2, 4, 6 for this one. Now by now, there's not exactly a pattern, but there are some things that you can note. First of all, each of these starts with 0 and 2, so each of these has a fair amount of semitones already. This one has the most, this one has an additional one, this one has fewer. If you look at just the set class name here, 0, 1, 2, 4, 6, you can tell that it has 0, 2, and 6 as a subset inside of it, meaning that this subset is also kind of present within this set class. Here it is, for example, I think. So that's good to know. They do have some things in common, even though they're not completely related by set class. Here we've got, this one will take a little less time, I think. We've got B, G, A, oh, and B flat. Don't forget the grace note. 0, 1, 2, 4. So once again, a 0, 1, 2 name. A 0, 1, 2 set class, shorter. I'm going to put it down here because just for space, basically. And it has that 0, 2, 4 that this one also has, and that this one also has. This has 0, 2, 6. And so you can start to see where, like this also has 0, 2, 6 in it. You can start to see where these patterns, or at least similarities, start to kind of show up. Let's do another of these longer ones here. So in the left hand, this is back. We had 4, 10, and 2. We already had that. Now it's back again. And here's this. We've also already had 3, 9, 11, but we're going to add to it 7. And I'm noticing actually as I do that I think it might be helpful to break this into 2 different sets already. And the reason is that I didn't notice. I was separating them by silence, but I think you can also separate them by grace note. So for instance here, this has its own grace note, and that's a big part of articulating each of these gestures, I think. So let's see what happens if we focus on it like that. So anyway, 7, that's already a pretty long set. Everything that's in the right hand after that repeats. Oh no, it doesn't, but it does with the next one. Anyway, let's not get ahead of ourselves. 0, 1, 2, 5, 6, 7, 9. So that is, again, a pretty long set, a 7-note set. 0, 1, 2, 5, 6, 7, 9. Actually, I'll leave it right there. So again, like the other ones, this is part of why I like putting things into prime form, because I feel like then you can start to see the similarities more easily than if you just listed all their numbers. So 0, 1, 2, well, that means it has that same quality in common with basically every other set we've heard so far. It has 5, 6, another semitone, 6, 7, another semitone. It has a tritone from 0 to 6. And the interval vector over here tells me that it actually has 2 tritones. So where else is there a tritone? Well, where else is there a distance of 6 between any of these numbers? 0 to 6 is 1. From 1 to 7 over here is another one. So there's our 2 tritones. So really there's quite a variety of intervals in this cluster. And then it also has 0, 2, 6, like some of the other ones that we've looked at. So you can start to really see things that they have in common. Let's do this one right here. Here we've got C in the bass, that's a C natural. We've got C sharp in the top voice, A and B. 0, 1, 2, 4 here. Notice that that's the same thing that we had over here, but it's been changed. Let's see if we can figure out now how those two might be related by making some notes. We could make our notes a little bit more consistent and comprehensive over here. So let's do that first, and then we will explore the relationship between those two sets. So we've got 0, 1, 2, 4, 5, 0, 1, 2, 5, 6, 7 with 0, 2, 6 kind of hiding inside of it. Or nested is another way of saying that. 0, 1, 2, 4, 6. We've got then 0, 1, 2, 4. Notice that that's almost exactly the same set, just without the tritone added onto it. 0, 1, 2, 5, but that's not all. 6, 7, 9. And then I said we just had 0, 1, 2, 4 again, and so we're going to see this one is related to the previous instance of 0, 1, 2, 4 by, and we're going to figure that out. So this is where I said it's really helpful to have some scratch paper. I find that to be a really helpful tool. Okay, let's have a look, see. Oh, let's get the actual pitches. For the first one, we've got 10 and 11, 7, and 8. For the second one, we've got right here 0, 1. Did I say 8 before I meant 9? 8 is 9. Here we've got 9 and 11. So once again, you can look at it and see, is there a way that you could sort of like order these up so that everything is only like a consistent interval away from everything else? And I would say right away I can tell that it's not just going to be transposition as the relationship, because 11 to 11 is the same, 9 to 9. I mean, you might think like, okay, well, if I added 11 to 0, it would come out as 11 or something like that. I don't think we're going to be able to, but let's see if I'm right. Let's go back over here. We'll do the first one, which was 10, 11, 7, 9, 0, 1, 2, 4. It's very chromatic for part of it, as you can see. Like, look at these 3 notes, almost like the chromatic scale. Okay. And we're trying to find a relationship that takes it to 0, 1, 9, and 11. 0, 10, 8, 11. I was wrong. 0, 1, 9, and 11. Gets there by T2. So let's put this in normal form before we add it. So that would actually be 7, 9, 10, and 11. And then if I go to 0, 1, 9, 11, nine, 11, 0, 1 is its normal order. And so then you would just need to add 2 to everything. Oops. Right? You can see how that's coming about. You end up with that. If you add 2 across the board, 2, 2, 2, then you end up with 7 plus 2 is 9, 9 plus 2 is 11, 10 plus 2 is 12, which is 0, 11 plus 2 is 13, but mod 12, that would be 1. So let's see also if this one reproduces itself at all under, let's see if this one reproduces itself at all under transposition and inversion. So anyway, I was incorrect. I couldn't see that well enough, but again, that's one reason I have the calculator. I think it's really useful until we've honed those instincts better ourselves. And I would probably have gone about that if I were working on this for my own analytical purposes in just the same way. So I think let's actually bring the notes back one more time. This is related by transposition of a second, a major second. This one's related to the previous 0, 1, 2, 4 by T2. Let's look at the score for a second too. See how you can see that everything here has just been moved up a half step, and that's all. Sorry, here. everything between this and this is just a half or a whole step apart. This next set is going to be very similar to 0, 1, 2, 4, but it has an additional note. So we've got 0, we've got 1, we've got 9, 11, and now we also have 7. 0, 1, 2, 4, 5, 6 for this right here. More semitones and a tritone this time. So that goes with that. And then we have this very long thing coming up. I think that I probably would start by just getting all of it together, even if I'm not sure that it's all going to be in the same set together. Notice that we've seen this before. This is our 4, 10, 2 that we've seen in the left hand 2 other times now in this set and at the beginning. Okay, so 4, 10, and 2. Now we also have C sharp, E flat, G natural. Confirm that with your ledger lines. That's a C, E, G, okay. We also have A and B natural. Natural C sharp we already have. A, C sharp, E flat we already have. So notice that we've got here a whole bunch of every kind of interval except only 3 tritones, only 3. So here's its normal form, and here's its prime form, 1, 2, 3, 5, 6, 7, 9. So notice that it does share some things with the other sets around it so far. I'm going to go ahead and label it here. 1, 2, 3, 5, 6, 7, 9. If I take that away, then it looks like this. If I did have the barrier there, okay, it doesn't. Okay, then notice that this looks a bit like what happens immediately before it, except there's more kind of going on. Let's look at it like this for now. It's got the 0, 1, 2. It's got the 5, 6. We've seen that before. 2 other times, 3 other times. It's got 7 and 9. It's a lot like this set, except there's one more note that E natural is happening in there too. Or excuse me, the E flat is not happening in this set, but the E flat is happening over here. So it's pretty similar to what we've seen before. And then finally we've got one more thing going on here, which looks like a pared down version of it. So we have that 4, 10, 2 in the left hand again. We have G flat in the right hand, A and B. So there's our 0, 1, 2, 5, 7, 9. Just a little bit different from what we've seen. So we've labeled all of these. We can see that they share certain qualities, and that gives it a sense of cohesion even with this many different subclasses. We talked about how this 0, 1, 2, 4 and this 0, 1, 2, 4 are related by, we said T2. We talked about how you can tell which kinds of intervals are present in there. And we'll talk about symmetry in just a moment. Okay, so now let's talk a little bit about sets, subsets, and symmetry. I didn't mean for those all to start with us, but here we are. So, okay, in this excerpt, not so much in the other one, I guess, but in this excerpt, we talked about how there were all these 012s, 012s, and then a couple of times, a lot of them also have a tritone, have that 6 present, and 026 came up as the subset here. So 026 is also, we didn't finish this, did we? Let's hit pause on that and go back to do this first. Where did we stop? With our 0, 1, 2, 4 here. So now we've got 0, 1, 2, 4, 5, 6. And then we had 0, 1, 2, 3, 5, 6, 7, 9. And then we had still 0, 1, 2, 5, 7, 9 at the end. I just wanted this list to be complete since we made a list. So we talked a lot about how you could have, 0, 2, 6 is the subset of this larger set. And you could also pull 0, 2, 6 out of this as well. Why did I not put 0 there? You could pull 0, 2, 6 out of a lot of these sets. There's one in here. There is a 0, 2, 6 within this. It's just not quite as obvious because the 6 is from 1 to 7, etc., etc. Okay, so 0, 2, 6 is significant because it is a whole tone subset. So 0, 2, 6 is a subset of the whole tone. I'll spell it out the first time. Whole tone scale. So what's the whole tone scale? Hopefully you remember that. Let's go back here, reset. So what's the whole tone scale? Only whole steps. 1, 0, 2, 4, 6, 8, 10. And there's a couple ways that you can kind of arrange that. There's sort of 2 whole tone sets, but 0, 2, 4, 6, 8 T is a common one. So 0, 2, 4, 6, 8 T is a way to express the whole tone scale as a set class. Notice that 0, 2, 4 is in there, 0, 2, 6 is in there, etc., etc. And you can actually arrange it several different ways on your you can pull out a bunch of tritones from it and arrange them on your circle diagram. We could also say, here are all the tritones. Let's just take a second and do that. Within that set, there's a tritone from 0 to 6. There is one. Where are all the places that you can connect with 6 from 2 to 8, right? So 2 to 8. From 4 to 10. So, and then after that, they start to repeat. So all of those are tritones within the whole tone collection, and we can actually call it a collection. We can refer to it as a collection rather than a scale, because it might not actually be acting like a scale, and scales really are collections anyway, so just go with that. The idea is that it's a collection of a pattern of whole and half steps, and in this case they're all whole steps. So there are some tritones within that, which means that this set class sounds pretty different from others that you are familiar with, right? No half steps at all, which gives it a very distinct sound, almost like very, very consonant except for all the tritones. Let me play it for you. It's often used to create a kind of sound that's sort of mysterious, ethereal, otherworldly, because there's no perfect fifth. So if we go back and look at our thing here, here's what the whole tone scale looks like for its interval vector. No half steps. 6 minor seconds. So you could still have no half steps, sorry. 6 major seconds. You can still have major seconds. No minor thirds. 6 major thirds or minor sixths. Makes sense if you look at it, right? There's a major third from 0 to 4 and another one from 4 to 8. So there are a couple of augmented triads hiding within it. No perfect fourths or fifths, and 3 tritones. So quite a few of those other ones. And that's why it sounds really distinctive to me. I really like it. I like the whole tone scale a lot. So another thing that's interesting about this set is that if we express it as 0, 2, 4, 6, 8, 10, the way that it is ordered here, you can see that it is symmetrical and that it's always a difference of 2, 2, 2, 2, 2, 2, as in 0 plus 2 is 2, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10. The whole tone scale is, let's go with collection, I just told you to do that, is a symmetrical subclass. It has the same pattern of intervals going backwards and forwards. There are other ones. I think with the piece that we looked at last week, The Amazing Grace, we were looking at 0, 1, 6, 7. It's also a symmetrical set class. And you can tell that because here's the pattern of intervals, not the interval vector, but the pattern of intervals here is 1, and then there's 5 between them, and then 1 again. So the interval goes a semitone, a perfect fourth or fifth, and another semitone. So it's that arrangement. Here, I'll note that so it's extra clear in the notes. Semitone, then 5, and then I guess I could have the arrow going that way. Semitone again. So it's the same backwards and forwards. There are lots of symmetrical sets, and symmetrical sets have special qualities, for example. Let's look at another one within the whole tone scale, or within the whole tone collection. There are multiple augmented triads. So if we wanted to just make an augmented triad, we would have, for example, C and E and G sharp would be 8. So we'll take everything else away. And you can see how that is also expressed symmetrically. It is only made of major thirds, so it only has an interval in its interval vector here for 3 major thirds. Or if I go my clock face diagram in the previous notes, I can show you how an interval vector, or how a augmented triad looks here. To say we would have C, E, and G sharp, which is kind of a cool thing. It almost looks like a peace sign. So that's 0, 4, and 8. But if you look over here at all of the ones we started with, we had 0, 4, 8. We also had, and I'll change colors to emphasize it, we also had 2, 6, and 10. And you can tell that that is also, what a pretty shape I've drawn. But you can tell that that's the same kind of peace sign shape that the other augmented triad made. So that is a way of showing that each whole tone collection is made out of 3 tritones or 2 augmented triads. It's just another kind of cool thing where you can see how this could rotate around, and each of them can change pitches. Like you could start the whole tone scale in a different pitch, but ultimately it would have the same, it would belong to the same set class. So symmetrical sets have different qualities. One is that they sometimes repeat themselves, like we talked about with 0, 1, 6, 7 under transposition, and sometimes also under transposition and inversion. Let's look at 0, 4, 8, for example, if we were to transpose it, or if we were to invert it. If you invert 0, 4, 8 along the 0, 6 axis, what happens? Well, 0 stays the same, 4 becomes 8, and 8 becomes 4. So there are 2 augmented triads. The augmented triad stays the same under inversion. So if you start with 0, 4, 8, and then you try to invert it by T, 0, I, as in just inverting it, not transposing it, you will still get 0, 4, 8, which is a cool quality of it. So Some sets are symmetrical. Being symmetrical gives them special properties, meaning that they either do or don't change under transposition and inversion. In a lot of cases, their symmetry means that they stay the same, which is cool. And symmetry also means that if you arrange them on the clock face, they can be represented in a visually symmetrical way in space. So I think that's all I want to tell you for right now. Segmentation will continue to come up as we look at more set theory and as we look at more atonal music, because it's certainly not always as clear as this. But part of the reason that I was initially attracted to crumb is because when you look at this, I feel like it's easier to imagine how to segment it in a way that reflects your experience of listening to it. And so that's partly what I liked about that. And that's what I was drawn to, because I had to choose a piece for my comprehensive exams to analyze. And having studied crumb in class, I thought, well, if I pick crumb, I bet that there will be a relatively straightforward way to segment it. And he is a fan of doing things like he did in this excerpt that I showed you, where there's a certain consistency or a certain pattern, some kind of relatively discernible way that he has organized his pitch content. And it often relates in some way to the narrative content of what's going on in the piece. One thing that I have always thought was interesting about this piece, so if you look at this, you play the left arm, you play the right arm, and then you play the center. And the moment that they strike in the center is interesting to me, because that's when the pianist has to shout Christe, and there's 7 seconds of silence again, that sort of like divine significance that crumb maybe assigns to this music, or to that interval. And notice right at that moment that we get 0, 1, 2, 4, 5, and we had 0, 2, 5 over here, and a lot of triads, and then we end up with this slightly more dissonant set to start that, the moment that, in a way that the cross is sort of built physically in the score. So I think that, without going into right now, I think that there are some really interesting narrative implications for that. That's something that I have studied before. Like, what does it mean that that's the case? And so I picked this because I wanted you to think about what it means to actually use set theory. It isn't just a robotic approach to studying music. It definitely has some subjective qualities to it, just like any method of analysis does. And especially with crumb, there's usually a way that ties into some kind of less abstract and more direct symbol or narrative or some other program that's going on in the piece. Anyway, I will be back next week with more, and I hope you have a wonderful week thus far. Bye for now.